So good afternoon. I'm Cuong Tran from Honda Research Institute. Today I will talk about some work that we have been doing in augmented reality in cars. In particular, I will talk about an AR navigation system that we have been prototyping and testing. So first we see that the car could be a very promising platform for augmented reality compared to other AR devices like smartphones or smart glasses. The car has a very large potential interaction space. We have a big see-through windshield that can be used for immersive augmented reality. We have more space, so we have more options for sensors and computational power. And of course, we transport with the car. And so there's a potential to develop the driving aid that can help to reduce the accident and save lives, which is very important. So beside the opportunities, we also have challenges. And this scheme roughly shows what we are trying to do. By providing visual AR stimuli, we want to enhance the driver perception, like increase the situational awareness of the driver. And based on that, try to alter the driver behavior, like to help the driver to have a better reaction time, or at a higher level, we can try to develop the good defensive driving skill. Because the concern is that if we do not provide those visual properly, then actually it can block the driver view and create the distraction visually or cognitively, and that might cause accident, which is a very bad consequence. We'll talk a bit about our 3D heads-up display, 3D HUD prototype, which is shown in the picture here. So this one is not a flat projection like other 2D heads-up display. With this display, we can put the visual actually into the environment and augment the object that we want in an immersive manner. And because we can really put the visual on where the object is, we don't have the dual focus issues or the parallax issues, so we don't have to track the head to compensate for the viewpoint change. Just some more details about the capabilities of our 3D HUD. So we can show the computer graphics at variable focal length from about 8 meters to theoretically infinity. We have the field view of about 17 degrees. And for comparison, most of the publicly announced heads-up display have the field view from 5 to 10 degrees. And with this display, we can show a computer screen, but now each pixel in the screen can have its own depth. So basically, we can have a 3D surface representation. So based on this 3D heads-up display prototype, this is the process that we use to create content for our 3D HUD. I will not go into the details, but I want to emphasize that we follow a user-centered design approach. And all the important activities, we try to do that in-house, including design, development, and implementation, as well as user evaluation. So first, next I will talk about an application that we think is promising, which we call personal navi. So the main idea of this one is to develop a navigation system that tailored to driver-specific situation and needs. So following our approach, we try to analyze the user needs and see what is the problem with the current navigation system. So there are some illustration of some of the idea that we have in the personal navi. So first one, we know that the traditional navigation system sometimes is kind of ambiguous. Like can tell us to turn in 200 meters, but for some driver it might be hard to understand. Turn in 200 meters mean the oncoming intersection or the one after that. Or in some situation we might have like more than one-way turn, and we don't know which one. So by using the 3D HUD, we can annotate where to turn directly on the windshield of the driver and in 3D. So there's no ambiguity, and also there's no need for the driver to look away from the road ahead. Another issue is that current navigation system only tell the driver to turn left or right, but they do not tell the driver whether it's safe to turn or not. So we want to incorporate the advanced driver assistance system into navigation. So as shown in this figure, we try to tell the driver to turn right, but be aware of the pedestrian is crossing. And we can also anticipate the driver needs. For example, sometimes when we approach the destination, we try to look for what is the current address, whether we pass our destination or not, and sometimes that kind of activity is stressful and unsafe. So we can try to show the label address in our 3D HUD and help the driver to resolve that problem. Or sometimes we approach the destination to realize that actually we need to turn back to find the parking because there's no parking at the destination. So with this one, I just try to show a clip that we capture from the rear car. And on the left is some preliminary user evaluation that we have published in the Automotive UI in 2014. So in our user evaluation, we see that compared to traditional navigation system, the direct annotation helps the driver to know where to turn earlier, as well as with more confidence, and reduce the time off-road, eyes off-road time. So because in here it's difficult to see the 3D effect in a 2D video, but at least you can see that the camera move a bit, but the visual stay fixed into the environment. So basically, some takeaway that I want to mention in this talk is that we know that 3D HUD in the car has some advantage. It can provide true augmented reality in an immersive manner. We don't have the dual focus problem or parallax issues. Some augmented reality driving aids, like the personal navi, have the potential to help the driver to reduce to help the driver, but we need to design those kind of driving aids carefully, so we don't distract the driver instead. And of course, one thing that we notice is that we aware that 3D HUD is not the solution for everything. So for example, in our experiment with the personal navi, most of users state that they prefer to have both the direct navigation instruction in augmented reality, and they also want to have the traditional navigation with the audio and the map that show you a longer term, like what you want to do. While the AR HUD is only good for what is happen immediate in the environment, like what you need to do next. So of course, we move forward, we will need a car ecosystem, and 3D HUD is just one component in that. And finally, I want to acknowledge my former and current team member who have been working on this project. Thank you.
Very cool presentation. So some questions about augmented reality in the HUD. There we go.
Just one question. Do you in any way track the driver that you can really work with a line of sight of a specific person, or do you have a fixed head-up display and simply ignore that people might move on the seats and have different positions of their head?
Right, so as I mentioned earlier, like in here we have the 3D heads-up display, so we really put the visual on where the object is, so we don't have that parallax issues when we move your head. We don't need to compensate for the line of sight issues. But of course, we also have a kind of a limit eye box that the head needs to be in that eye box, but you can move inside the eye box. When you move outside the eye box, you will not see the content on the HUD. But when you're in that eye box, then that doesn't matter, the line of sight.
Other questions? I have a, there we go.
In the video, I see your system located parking spot, right? I'm wondering how it knows where is this parking spot.
So currently on this prototype, we use the 3D map that we have, and then we use the DigiPass information to localize our car where we are in that 3D map that we have.
So if the parking space is like behind you or to the right side, and can have an indicator?
No, so that's one thing related to how we design the content on the HUD. Of course, because the field of view of the HUD is limited, so we have a lot of situations when the content is out of the field of view. So how we show that information is like we need to go to the design. Like for example, in the video that I show, when it's out of the field view, we still show the parking, but then we have a line to connect to where it is in the, it might be on the side, but we have the tube that connect to tell the driver roughly you need to turn to that. And when you turn to that direction, you can see the actual position of the parking.
And it looks like we have one last question up here.
Hi, is the accommodation distance of this display at infinity, or is it where the physical display is, or what?
Yeah, so because we try to, here we put the virtual image up at the position of the object, so the accommodation wouldn't be exactly at that. Like if you have a 2D heads-up display, right, and you try to simulate a 3D information, then the accommodation wouldn't be on the display, but the stereo, you try to put it like further away, so there's a conflict between the two. But in this one, we actually try to put the visual at where the object is, so it's consistent between accommodation and the stereo depth.
But it's not just that the depth is there, but the accommodation point is also there.
Yeah.
Okay, great, thanks.
And looks like we have time for.
How do you vary the depth of each of the pixels?
So because it regarded to the underlying mechanism of the 3D HUD, but I'm trying to be a bit careful about what I'm allowed to talk about and what I'm not.
This is only on video, don't worry.
Yeah, so I think basically at the high level information I can talk, like we might have a moving screen and it will go through an optic system that try to expand that kind of small movement to a longer distance in the real world, so we can vary the depth of the visual that we want to show.
Awesome. Thank you very much.